set, there's going to be lots of vocabulary here. So a set is a collection of objects. An element is one object in the set. Set notations use braces to show the elements of a set. So these are those fancy kind of brackets that a lot of people have a hard time making. You know what I'm saying? Like this. Yes? Yeah? Okay. A relation associates the elements of one set with the elements of another. There are many ways to represent a relationship between two sets. Be prepared to recognize these terms and match them to different representations. So you have to use words, tables, diagrams, arrow diagrams, bar graphs, ordered pairs, and line graphs to represent the elements in the sets. Okay, so here's example 1. Consider the set of fruits and a set of colors. Fruit equals apple, banana, blueberry, cherry. Colors red, green, yellow, blue. Yes, green apple, sure. Green apple. What did you say? Blueberry. Yellow. Banana. Would you say green what? Red apple? Red cherry. Red cherry. Any other ones? I'm sorry? Orange. If you want, sure. Orange. Does anybody remember what that's called in English language when the same word means two different things? Is that what it is? Cinnamon? I can never say that right. Okay. All right, ordered pair. So an ordered pair is like an x comma y. Okay. So do you want to have the color as your independent and your fruit, I guess, as your dependent? Or what do you think is the, depends on what? I guess the color depends on the fruit, hey? Rather than the fruit depends on the color. Yeah, so we're going to do the apple first, comma, green, blueberry, blue. I'm not going to write all of them out again. Banana, yellow. This seems a little redundant, hey? Apple, red. Okay, now we're going to do it as a table. Oh, and maybe we should read this thing in the box here. Order is important. It is possible to go from the set of fruits to the set of colors, but not from colors to fruits. It's okay to say an apple is red, but it's not okay to say the color red is an apple. Therefore, the relation is directional. When I wrote it as words, the order didn't necessarily matter as much. Now when I'm doing it as ordered pairs, I talked about things depending on other things. So watch that when you're doing this. So when we're doing a table, what would we have in our table? What would we have in our table? Color and fruit. And so what would go first again? Yeah, our fruit. And then color. Okay, so I'm just going to list a few. It doesn't we don't have to list them all. Apple, blueberry, banana. Okay, so we're going to go red, blue, yellow, apple. I'll do again as green. That's probably good enough. Okay, so now the arrow diagram. This is where we're going to have basically the fruit in one, and it's going to the arrow. So that's why it's good we have apple twice, because then we're going to have, it's going to go across to red, but it's also going to go to green. Do you see? We don't have another one that has second. Do we have any others that repeated colors? I guess red cherry, right? Let's do cherry is a red. Do you see? Then I don't have to list it twice. Banana, yellow. Okay. When the element of one or both sets are numbers, the relationship or the relation can be represented as a bar graph. So here's another example, and they represented the maximum speeds of different animals on this bar graph. So you're reading the bar graph and you're going to put it into a table. So what would go first in the table? Sorry? Animal, yeah. Animal. And then what will go here? Speed. You could say max speed. Okay, so now we're going to do bison. Well, can anybody read that for me? What's the speed there? 35. And maybe I'll put in here the unit. So this is kilometers per hour. Okay, then we have a cougar. You can read that one for me. 55. Does anybody know what this is called when it goes 0 and there's little kind of squiggle and then the 30? I'm sorry? Yeah, it's called what's called a broken graph. So when you label things on an axis, it has to go up by a scale. So do you see, everybody could read it was 35 and 55. It was going up by 5s. But notice that the first tick wasn't 5. And anytime that happens, you have to do this little squiggle. It's supposed to picture that it got squished down, right? So if you ever establish a scale and it's going 0, say 0, 30, and then the next one's 35, you have to use a broken graph. Otherwise, you will be docked marks for incorrect scale. Okay? So you don't have to do a broken graph, of course, if it goes 0, 5, 10, 15, whatever. But when I'm establishing a scale of going up by 5s, but this didn't start at 5, then I have to show it as a broken graph. Okay. Have you seen that before in science or something, or first time? First time? Okay. Good. Okay, coyote. What was coyote's max speed? Ooh, what would that be? Yeah, I would say 68 or 69. It's hard to read that, eh? Okay, grizzly bear. What do you think that would be? Grizzly bear is what?
47.
Yeah, it's almost like it's a halfway thing. So yeah, let's do 47. And then we have white-tailed deer. White-tailed deer. What's that? Same thing, eh? 47. Okay, so now I want you to put this into an arrow diagram. Do you remember what an arrow diagram looked like? You can see it actually on the next page too if you don't remember. Here's an arrow diagram. Yes? Okay, so I'll give you a second to try that. So the one that has 47 twice, you would only have to write the 47 once, right? And then have 2 arrows going to it. Okay, so we have bison, cougar, coyote, grizzly bear, white-tailed deer, and then we have speed is here, so we should probably put the speed in order. I didn't really mention that, but okay. So I'm going to put this in order. So 35, and I didn't mention that. It's just a better organizational tool. if it's numbers, right? Would you get it wrong? No. As long as it's going to the correct one, it's fine. And then these are going to grizzly bear. Okay. Otherwise, it just looks straight across. Okay, if it says an arrow diagram and you don't put arrowheads on it, that would be a deduction. It's going one direction, not both ways, right? Okay.